We will focus on tool catalog and its manipulation in TISIS. You see our program for the sample part with part info section already defined. To open tool catalog, let's click Tools, and we have Tool System 1. It represents Gang 1, it means main operation. Tool System 2, respectively, represents back operation. Let's compare Tool System 1 in TISIS with configuration of our DT26HP machine for the sample part, as you see in the photo. At the first glance, you see the difference that we have in TISIS chisel for 6-tool 12 by 12 mm cross-section, but in our configuration, this is chisel for 5 tools. Let's open Tool System 2. There is nothing defined in TISIS, but in our configuration, we have holders assembled on all available fixation points. It means that we have in TISIS to select the same type of holders as in our configuration and also define the same DERA layout. Our first step is to delete this 6-tool chisel. It is easy to do, just click this X symbol. But please notice that this red triangle appeared on the left side. It shows that there is at least one error in our program. To check it, we should open Addition section, and we have altogether 4 errors. To locate them, we can click this red triangle in channel 1 and in channel 2. The reason for these errors is that at least cutoff tool is necessary in a program. That is why don't worry about these errors, they will disappear when we add tools. Let's return to our tool catalog and add first holder. Click Add Holder icon. On the left side, the list of all available holders to assemble on Gang 1 is displayed. We have to find in this list our 5-tool chisel. This is our holder, let's select it, and on the right side, TISIS suggests us the list of all fixation points where we can assemble the selected holder. In our case, this is only one fixation point, 13, so let's click it, and holder is added. You see in our configuration that next we have 3 transversal driven holders and B-axis. First, let's look on B-axis. This is our B-axis, but you see that this is gray. It means that in current configuration defined in TISIS, it is not possible to assemble B-axis. We need other driven holder to transfer rotation to B-axis. So let's begin with those transversal holders. We have to find this type of holder. This is our holder, and we can fix it on fixation point 14 or 15. Let's click 14 and once more check B-axis. Still it is gray, so one more holder, and now our B-axis is available to assemble. We can conclude that to assemble B-axis, it is necessary to have the other holder on PF15 to transfer rotation. And of course, we can add the third holder. Now we have all transversal holders, and this is the turn to fix B-axis. Let's click it. The only available PF to assemble B-axis is PF30, so let's click it. And you see that now our Gang 1 is full. We cannot add any other holder. And we have the same configuration as you see on Gang 1 in our photo. So let's continue with back operation. To move to back operation, click Next System, and what you see, this is available equipment to assemble on B-axis, but we don't need it, so we can skip it, click once more Next System, and this is our back operation. We will start with this driven holder on left position, T540. So let's select this type of holder. This is our holder, and we can assemble it on PF54 because there is output of a drive. So let's click. And as you see, we can add adjacent the same holder, but we don't need it. Instead, we would like to fix two stationary holders of hole of 22 mm diameter. So let's find this type of holder. This is the holder, and fix it on PF53 and PF52. The last three fixation point, 51, should secure double stationary holder. So we have to find it. This is our double stationary holder. Click on PF, and gang 5 in back operation is full. This way we completed selection and placing of holders needed for our sample part. We have the layout the same as in the configuration in photo. So we can click Close Window. Our task now is to place tools which we need on selected holders. Let's start with cutoff tool on position T130. This is this position. To add a tool, it is enough to click this plus symbol. If we would like to delete a tool, then we click that X symbol. And the next step is to select among pictograms that one which corresponds with cutoff and add comment. Please notice that with adding cutoff tool, this red triangle representing errors disappeared. Let's now compare geometry in X and Y axes shown in TISIS with those ones in kinematic drawing. First, X-axis. Here we have the value 20, this is given by radius, and it is our 40 given by diameter. And in y-axis we have dimension 12, and the same is in the kinematic drawing. Geometry of cutoff tool in z-axis needs some words of comment. 0 in this geometry is located at the bottom of a slot here, and it is, we can also say that it is on the back side of this insert holder. Below you see the drawing of our cutoff tool, so this is at this surface and this edge we have 0 of geometry. We have here two edges of an insert, and I'd like to emphasize strongly that when we determine the geometry of cutoff tool in z-axis, we take distance from this left edge, this edge, to the bottom of a slot or to the surface, this side of insert holder. In our case, it will be width of the insert taken with minus sign. Why minus? Because Z1 axis has direction plus here and minus in this direction. We already defined the width of this insert in part info section and cutting form. Here you see 2 mm. So returning to our cutoff tool, we'll enter as geometry in Z -2. Next tool is front turning tool on position T131. So let's add it. Geometry is the same, so doesn't need comment. And the next one is grooving tool T132. Let's add it. And geometry in X and Y is the same. Please look at this drawing of our grooving tool. We can use in machining two edges of this insert. The left one to machine the left side of a groove and right one to machine the right side. In this situation, we can use in our program directly dimensions from the drawing. But in TISIS, you see that we have only one geometry. So what to do to create the second one? Just click this arrow down. And now we have two geometries, D0 and D1. We can decide that this right edge will be our geometry D0 and left one, this opposite one, will be our geometry D1. In this case, geometry Z0 for D0 is the correct one, but for D1 we have to enter -2. At the end of discussion of our grooving tool, I'd like to draw your attention to the possible conventions of writing tool numbers. First, we have to say that the geometry D0 is the default one. That is why we can denote our grooving tool like you see here, or we can write just T132, omitting this D0 because this is the default geometry. The other possibility is to add the number of geometry at the end of tool number. Taking D1 geometry, we can write as you see here, or also we can add geometry number at the end of tool number. This second convention we already used in part info and cutting form when we determined the number of cutoff tool. Let's continue with transversal driven tools. We have to add centering tool on position T140 and drilling on T150. And let's compare geometry in x-axis of those driven tools. Here in TISIS we have 88, and in the kinematic drawing, please notice, we have 44 as the length of our tool in x-axis. This 44 is 88 byte expressed by diameter. And now b-axis. We have to add taping tool on top position T300, after it a drilling tool, and at the bottom centering tool. So let's do it. These are all our tools to assemble on B-axis, but please notice geometry in Z-axis of all those tools. Please look that it is exactly the same value as the length of tools assembled on B-axis given in the kinematic drawing. Let's pass to back operation. Click Tool System 2 and we'll start with centering tool on position T540. This is driven tool. So let's add this tool. The next one is drilling tool on adjacent position. Please look at the geometry in the Z-axis. This 63 is exactly the length of a tool shown in the kinematic drawing. For stationary tools, we have slightly smaller length. Let's discuss now external turning tool on position T510. Sorry, I've made a mistake. because it should be position T510, but it isn't a problem. I'll take this opportunity to show you that we can cut, copy and paste tools in tool catalog. So let's cut it and paste on the right position. We have to say that surely this kind of tool doesn't have geometry in x-axis equal to 0. The correct value we can find in a tool catalog of a manufacturer, and in our case this is 30 millimeter. But the question is if it should be plus or minus 30. In this drawing, you see the situation where the center of a part in back spindle is in a line with the center of a holder. And please look at the drawing in the bottom. Here you see that to have center of a part in a line with this tip of a tool, it is necessary for back spindle to move in this direction, but this is direction in minus in axis x4. That is why we should enter here as geometry minus 30. And exactly the same situation we have with external threading tool on position T511. So let's add this tool. Our last tool is internal turning tool on position T520, so let's add it. And for this tool also, surely geometry in X isn't 0. We know from the catalog that the distance from the center of a holder to a tip of a tool is 1.6 millimeter. And to have center of a part in a line with this tip, it is necessary for back spindle to move in the same direction of minus as in the case of external turning tool. That is why here we entered as geometry in X minus 3.2. We complete it in this way, defining and locating of all needed tools. Surely you've noticed that there is third tab in our tool catalog, free tools. Let's open it. Free tools are tools which are not assigned to any support. And here you see two special tools. The first one, T400, represents back spindle. You see here in the kinematic drawing T400. It is our back spindle. And normally geometry of back spindle in all axes is 0. But we can imagine such a situation as shown in this drawing, where collet in back spindle has some length. And then this length we put as geometry in z-axis. And what is T500? This is the position of back spindle to eject a part. Here you see the back spindle at position to throw away a part into this box, and this position in x-axis is by diameter 656 and in z-axis 249. And please notice that exactly the same values we have given by TISIS.